Okay, so today we're going to start chapter 7. We're going to be using the same identities that we learned in chapter 5. So the reciprocal identities, the quotient identities, and the Pythagorean identities. We're also going to be practicing our basic algebra skills like factoring, distributing, adding fractions. However, the difference is instead of adding fractions like 1/2 plus 1/4, these are going to be fractions that have trig in them. So, and then you're going to replace them. So we're going to be doing a lot of substitution. And then in section 2, we're actually going to be proving these identities. So, all right, so here we go. Again, same identities that we saw in chapter 5. Everyone should realize the reciprocal identities. We've been using those a lot. That the reciprocal of tangent is cotangent. Reciprocal of cosine is secant. Reciprocal of sine is cosecant. Now, we did see the quotient identities in chapter 5, but we never used them. But we will be using them now in chapter 7. So tangent is equivalent to sine squared, or not sine squared, sine theta over cosine theta. And cotangent is cosine theta over sine theta. And then we have our 3 Pythagorean identities, which we used also in chapter 5. Now, you need to be able to manipulate these Pythagorean identities and be able to recognize different versions of it. And what I mean by that is maybe you'll be given an equation and you're going to have maybe a sine squared theta that you want to replace with something. So what we can do is take this first one and we could solve it for sine squared theta by subtracting cosine squared theta to both sides. So we would get what sine squared theta equals, which is going to be 1 minus cosine squared theta. We could do exactly the same thing and solve it for cosine by subtracting the sine. So be able to manipulate these 3 Pythagorean identities to different versions of itself. Now, everyone seems to be able to memorize this first one. Sine squared theta plus cosine squared theta equals 1. But these two seem to give people trouble. So come up with some kind of trick to help you remember it. Maybe for the last one, realize that these are both reciprocal identities and they both start with the letter C. Or maybe this is the only reciprocal identity that we didn't use and it goes with tangent. Find some way to help you memorize these 3 and be able to manipulate them to other versions. We'll also be introduced, instead of the theta symbol, sometimes they're going to write the identity as tangent squared x plus 1. So instead of using theta, they may use the variable x. All the theta and the x represent is the angle measure. So whenever you're doing these, do not write your answer as tangent plus 1 equals secant squared. You need a variable or something to stand in for the angle measure. So you need an x in there, you need a theta, something to represent the angle measure. When we simplify, we don't want any fractions. So we're trying to simplify as low as we can, and we're going to be replacing each of these with either a quotient identity, a reciprocal identity, or a Pythagorean identity. Now, when the 3 things are being multiplied, we're going to go back to like our 3rd or 4th grade math where we multiplied fractions. So because a lot of these are going to be the reciprocal identities. So remember when you did like 2/3 times 9/10, and you can simplify diagonally. I could have changed the 2 to a 1, the 10 to a 5, and then same thing here, make this a 1, make this a 3, and then multiply what remains, and you get 3/5. We're doing the same thing here, but instead of numbers, they're going to be words. And we're going to simplify diagonally. Now, some of the problems are going to have plus and minus signs. You can't simplify diagonally when it's a plus or a minus, only when you're multiplying. Notice these 3 trig functions are all being multiplied. So I'm going to be bringing in my reciprocal identities. So what is the reciprocal of secant? Cosine. So I'm going to change this to 1 over cosine theta. What's the quotient identity for cotangent? So it's going to be cosine over sine. Now, for the sine, I'm going to leave it alone because I'm trying to make things become something that's similar that's in the bottom of my fraction so I can cancel. Now, remember, when you simplify diagonally, it doesn't make it disappear, it becomes a 1. Just like I did up here with my fraction. See how I did the 3 and the 9? And the 3 became a 1. Okay, don't forget your thetas. Thank you. So on the middle one, this needs a theta. Yes. All right, so now let's look for things to simplify. You can only simplify on the diagonals when you're multiplying. So I could simplify the 2 cosines. They're going to turn into both 1s. And then I can simplify the 2 sines. They're going to also turn into 1s. Now I'm going to multiply what remains. And 1 times 1 times 1 across the numerators is 1. 1 times 1 times 1 across the denominators is 1. So this simplifies to 1. Use the reciprocal identity. I used the quotient identity, and then I left that last one, the sign, just itself. And then I looked for things to cancel or simplify. So let's replace the cotangent with its quotient identity, which is cosine squared x over sine squared x. And then this one is a Pythagorean identity, and I know that that equals secant squared x. And again, these are being multiplied. Again, I don't want any fractions, so I can actually change my secant squared x to its reciprocal. So I'm going to change this into 1 over cosine squared x. Let me rewrite the red, because now I have something diagonal from it that it's going to cancel. So then I can cancel the cosines. They become 1s now. And now I'm going to multiply what remains. So 1 times 1 in the numerator. Sine squared x times 1 is just sine squared x. Again, remember, we do not want fractions. So now I'm going to use my reciprocal identity, and this becomes cosecant. And that's your answer. 1. Notice we've got some binomials here. So guess what we're going to be doing?
Foiling.
Foiling. Woohoo. All right. Let's FOIL this. So first, secant x times secant x becomes secant squared x. Outside becomes plus secant x because it's times 1. Inside becomes minus secant x. And then last becomes minus 1. Notice the middle terms are going to cancel out. So this will cancel. And now I'm left with secant squared x minus 1. So this is your Pythagorean identity. And remember that tangent squared x plus 1 equals secant squared x. I can manipulate that and move the 1 over, and you can see that it's tangent squared x is equal to what we have in our problem. So final answer here is tangent squared x. All right, so this one's got a little star. So we're going to do this one a little differently. So this has actually been simplified and gotten a common denominator. So what I'm going to do is I'm going to give each one of those numerators its own sine x denominator. So I'm going to pull it apart. So I'm going to rewrite it, and I'm going to give cosine x its own sine x, and then sine x its own denominator of sine x. And now I can simplify. So I can see now this has got a plus sign. So I can't simplify diagonally when I'm adding two things. So I'm going to just simplify each term separately. So the red one, this is cotangent. And anything divided by itself is 1. Now, okay, now, this is not a Pythagorean identity because remember the Pythagorean identities have a square in them. So this is as simplified as it gets. At first glance, you may think it's that Pythagorean identity where it's going to be equal to the cosecant, but there is no cotangent, there's not a square on the cotangent, so this is my final answer. So remember, the Pythagorean identities need squares in them. Yes. Number 5, these are both, or at least the top is a manipulated identity. The bottom is actually one that you're memorized as that way. So again, what we're going to do for the top, the identity that we're going to manipulate is the sine squared x plus cosine squared x equals 1. I'm going to solve for cosine. So I'm going to move the sine over. So cosine squared x equals 1 minus sine squared x, which is what I have on the top. So that's just cosine squared x. The denominator is going to be the way that you memorize it. 1 plus cotangent x equals cosecant squared x. So that's what I'll put in the bottom of my fraction. Now, again, we don't want fractions, so I'm going to turn that denominator into its reciprocal.
1 over sine.
Good. So I'm going to turn the denominator into 1 over sine squared x, and then put the cosine back. Now, remember, this fraction bar means division. So what we're doing here is cosine squared x divided by 1 over sine squared x. I got to do a keep, flip, change, or a stay, change. So this becomes cosine squared x times sine squared x, and I'm done.
You're allowed to have multiplication?
Yes.
Wait, can you go back?
Yes. So that's the final answer there. Just don't leave anything as a fraction. So you could also write it, if you want to flip it around, and write the sine first and then the cosine. Remember, multiplication is commutative. So you could write your answer either way. Doesn't matter the order that we write the multiplication. So we actually have 2 binomials here. So we're going to FOIL. This one's not going to be as nice. It's not going to cancel out the middle terms. We're actually going to get 4 terms that we're going to have to turn into some reciprocals. So let's go ahead and multiply first. So secant times cosecant. So secant x times cosecant x. Then outside gives me secant x times sine x. Inside gives me cosecant x times cosine x. And then finally last gives me cosecant x times sine x. Anybody realize what we're going to get when we multiply something by its reciprocal?
1.
Good. So my ends are going to become 1s, but I'll show you what I mean by that. So secant, the reciprocal of cosine. So if I turn this into 1 over cosine x and I times it by cosine x, this simplifies to a 1. Same thing's going to happen on the black end. This is 1 over sine x times sine x, and this becomes a 1 also, a negative 1. Now the middle part, it's not going to simplify, but I need to turn it into its reciprocals to see if anything's going to simplify to something I know. So let's do the blue one. The reciprocal of secant is cosine, and then I'm going to leave the sine x alone, because this will simplify to tangent. Because when I multiply it, and I'll just write it first, sine x over cosine x, then the green reciprocal of cosecant is sine, leave the cosine, And again, this will simplify cosine x over sine x. Notice the 1 at the beginning and the end, 1 minus 1, and these are going to become 0. I can simplify the blue. This is tangent. It's got the negative sign there. And then the green is the cotangent. So you can either leave your answer like that, or you can flip it around. So you could write it as cotangent minus tangent. Either way is acceptable, okay? These are actually two Pythagorean identities. So the first one, remember, is the tangent squared x plus 1 equals secant squared x. So that's what we're going to replace the top with. And then the bottom, this is the 1 plus, just like it is, 1 plus cotangent squared x equals cosecant squared x. So that's what I'll put in the denominator. But again, remember, we don't want to leave things as fractions, so we're going to turn them into their reciprocals.
Cosecant is 1 over secant.
So cosecant is 1 over, this one's sine,
Oh, no, cosine.
and then this one is 1 over cosine. And again, we're going to do keep, flip, change, because this is the division bar. So 1 over cosine squared x divided by this, so flip it to its reciprocal. And this needed a square, over 1. And then now I get sine squared x over cosine squared x, which equals tangent squared x. Final answer. All right, so we did this in chapter 5. So here they're giving us what cosecant equals. And remember, cosecant is the reciprocal of sine. So here it says it wants us to find the angle in quadrant 3. So here we're going to use an identity to find secant x. Now, when you do the homework, just like you did in chapter 5, they're going to ask you to find all 6 trig functions. So you're going to have to find sine, cosine, cosecant, secant, tangent, and cotangent in the homework. This one's only asking you to find 1. So let's go ahead and look at what we're given. We're given cosecant, and we're asked to find secant. So we need to think of an identity that might help us. And the identity I'm going to use is going to be the sine squared x plus cosine squared x, because both of the things in my problem are the reciprocals of both of these. Is we were given cosecant x is equal to negative 5 over 2. So I know the reciprocal, which is sine, is going to be the reciprocal of that. So I just flip it upside down. So what we're going to do is plug in 2/5 for sine squared. Now, on the chapter 5, a lot of people forgot to square things. And that was where people made mistakes. Now, what I'm going to do here is, now that I've plugged that in, I am going to square it and solve for cosine. So this becomes negative 2/5 squared becomes 4 over 25. I'm going to change my whole number 1 into a fraction so I can subtract and solve this. So I'm going to make it 25 over 25. Now I'm going to move the 4 over 25. So cosine squared x equals 21 over 25. In order to just get plain cosine, I need to square root both sides. So cosine is equal to plus and minus square root of 21 over 5, because I could square root the 25. However, remember, it told you in the problem we were in quadrant 3. So let's do our all students take calculus. Remember, in quadrant 3, only tangent's positive. So this tells me get rid of the positive. So my cosine x is equal to negative square root 21 over 5. I wanted secant, so I flip it to the reciprocal. So secant is equal to negative 5 over square root 21. I need to rationalize. So final answer for secant, which is what they were asking me, is -5 square root 21 over 21. Now, in the homework, they're gonna ask you to find all of them. So again, you could go back and plug them in. So for tangent, you would divide, cotangent divide. We already had cosecant, we have cosine, we have secant. So now it's a matter of going back and getting, well, we already found sine also. So it's just a matter of finding cosine and you divide it. So homework is page 610. This is not due until Tuesday, but again, try to start it. On Monday, I'll do some additional examples just to reinforce this, but try it. Don't wait till I try to do them. The more practice you do, the easier it becomes.